Okay, can you see me? My presentation? It's okay, okay. Dear colleagues, let me first thank Carolina, David, and Russ for very exciting overviews of political, social, scientific aspects of the project. I will touch upon only some part of the project, important part, as I understood from the talk, from the speech of Carolina. She mentioned it. It's a NEO problem. NEO, N-E-O, stays for nearest objects. First of all, I begin with the definitions. Let's look at the Wikipedia, and you see that what is the definition for transient astronomical event. You see that is an event often shortened by astronomers as transits, and it is astronomical object or phenomenon, which duration may be from seconds or day, weeks, and several years. And the examples of these events, these objects are supernova, nova, gamma ray burst, tidal disruption, gravitational, and so on, comets. I will add here NEOs also as a transients. Near source objects are minor bodies of solar system. If its closest approach is perihelion is less than 1.3 astronomical units. There is a subset of NEOs, it's so-called potentially hazardous objects, PHO. These are NEOs having a minimum orbital intersection distance with the Earth, 500 of astronomical unit. Why they are named so? That's because we have not the exact knowledge of exact orbit, and we couldn't forecast for centuries the exact position of the bodies. So potentially hazardous objects, these objects that could be in principle in very dangerous neighborhood or even in collision with the Earth. Another term is the asteroid comet hazard impact, ACH, is a threat of collision of the cosmic body with the Earth. We are interested not in all collisions, but only with those which are frequently, reasonably frequent and devastating. For instance, we are not talking about the collision with the 10-kilometer asteroids or comets happened 65 million years in Yucatan. We just consider in practical sense the bodies which could hit the Earth on the lifetime, not of person, but of humankind, say 100,000 years. So I think that the main conclusion, they will be given with these red letters. NEOs, and especially PHOs, are transients. They appear, they vanish, they couldn't be very frequently forecasted, and so on. NEOs observation is a good example of synergy between basic science and the problem of major practical significance for humanity, ACH. The science, I will not touch upon science, but it's really deep science related to the evolution, dynamical evolution, physical evolution of solar system, and so on. I will mostly touch on the ACH. The major data in one slide, these are NEO statistics. They are extracted from National Science Technology Council report in 2018. You see in the left panel, you see that estimated number of nearest object asteroids. Most of nearest objects are asteroids. Only less than 1% of them are comets. That's why I will demonstrate here the statistics for asteroids. You see in this graph that in red line, it is a predicted number, this theoretical number of bodies of different size. The size is in kilometers here. And you see that there are a lot of bodies like Chelyabinsk do exist. And my American colleagues, they put the Chelyabinsk event in the so-called non-devastation zone, but in fact, it's not true because the 400 kilotons is a devastative potential, of course. if the trajectory of this body will be steeper, then probably the Chelyabinsk will be destroyed, or would be destroyed in this situation. Nevertheless, what we know that we know now a lot of information we have about largest body. In the right side, you see that there are completeness, the percentage of nearest asteroid discovered, the completeness of our knowledge is close to unity, to 100%. But we know almost nothing about the very small bodies, which are very small, but still dangerous, like Chelyabinsk and up to Tunguska. You see, the level of knowledge is very low, close to 0%. The statistics of discovery, the huge amount of bodies is still rather poor. It's changing each day, but nevertheless, what we have now, we have information about 24,000 nearest asteroids, and we know almost all possibly dangerous asteroids larger than 1 kilometer, but have no information, not enough information about this region or these bodies. The primary task of the network, as it concerns the NEO issue, is to detect NEOs in this interval from 10, 15 to 500 meters. So let me introduce also the so-called modes of detection. Large distant mode, it means that you will detect the dangerous body, large one, larger than 100 meters, at the distance about 1 astronomical unit and larger. There are some facilities for this. Pan-STARRS, Zwicky transit facility, and the future LSST, they will be mindful instruments. But when you are talking about smaller bodies, decametric bodies, you need other instruments, because you have the cadence very short time for the cadence. You should to look at whole sky for several hours only. You can rapidly scan entire sky many times per night, and you need the instrument, many instruments of smaller size, like Atlas is shown here. We argue here that network of 1 meter class telescopes seems to be good compromise between complementing the capabilities of existing instruments working in both modes. I will not stop here. That's thanks to David that he explained this diagram. What is the idea now? That's the first step. It is planned that each BRICS country will host a 1 meter telescope of this class. Main advantage of the network is longitudinal and latitudinal distribution of the observation, the favorable for such a network. In the flagship proposal, you see in section 3 that ultimate aim of this ambitious BRICS flagship astronomy program, namely to construct a network of 70 global distributed optical 1 meter telescope. Of course, it refers to a fantastic, very exciting, very ambitious plan of our Chinese colleagues at CTAN that will be talked by Jifan Liu a few minutes later about this fantastic project. But now that's what is the closest prospect is we need to have some 3, 4, 5 prototype new wide field telescopes. I think that the first step is developing the optical design of wide angle 1 meter telescope. Russia is ready. Optimality means that high efficiency and reliability and also a reasonable cost. Russia is ready to participate and work on design and construction of a new 1 meter telescope. I just demonstrate a few slides about our experience. The current experience, which is behind now, we have constructed in 2015, 2018 a telescope AZ 100 wide field, WF. It is a more or less standard telescope, but with a larger wide field of 3 degrees. We succeeded to construct this telescope for quite, how to say, the budgetary, that's money. Now we are working on the optical scheme. Some of the optical scheme were demonstrated by David in his talk. It is this optical scheme of a new telescope was announced last year and the BRICS meeting in Brazil. It is a Hamilton scheme. We have discussed a lot of technical things, not now. We will discuss later with colleagues who are interested, involved in the telescope construction. But it is not stopped. I will present the next ideas of the telescope. It is not a Hamilton scheme. It is called Zonefeld type design with the Mangen mirror. It's very interesting. I also will not dive deeply in the technical details. I only say that we need to have a rather large field of view. Here, not 25, but nevertheless large enough, up to 20 square degrees. It's quite good. You could contact even now. Andrei Shugarov is attending our meeting, and he could comment on some ideas. The idea of this scheme is that all the surfaces are spherical. They are easy to, from optical point of view, to be manufactured. Also, we are looking for the cameras, and also we have now in hand some unit which could be used for such a telescope. It's not the final decision, of course, but it is just an example of a very good solution based on the Chinese sensor GSM, and so you see this specification. And conclusions. Conclusions is just a list of that statement which were presented in red. And I think that the most important, now I add the last line here, we need to have closer cooperation. We are ready to work on in all fields, in construction, design first, design of the telescope, optical scheme, and the telescope with our Chinese colleagues. We have good contacts with them. We are ready to work on the very important, there's a big data problem with the data processing for such an ambitious instrument. We are ready to work, and thank you very much for your attention.
Thank you very much, Boris Mikhailovich. Questions, please. I do not see any questions in the list, so thank you very much again, and we'll move to the next speaker, last speaker of the session, Chenzhu Kui from China, who will speak about Chinese vertical observatory and FAST.